Hello students, now in this video we will continue exercise 8.1. Now question number 9. Okay, it's given 99 to the power 5. Now how to evaluate this? Using binomial theorem. Simply if you do in your calculator 99 to the power 5, you will get one answer. But the question is asked using binomial theorem. Evaluate this. That means my binomial theorem formula is x plus y to the power n. Therefore, summation of n are equal to 0 and CR. And therefore, x to the power n minus r and y to the power r. This is your binomial formula, isn't it? Now, using this formula, I have to evaluate this. Now, you see there are two terms here, x and y. But I have only one term. So what we are going to do, we are going to split this 99 and make it look like something x and y value. Okay, 99 can be written as 100 minus 1 to the power 5. Okay, why I am writing 100 every time? Because with 100 my calculation becomes easier. Okay, some of the questions are there, it's given 101. If it was 101 to the power 5, what I will do is, I will split it up with 100 plus 1. But each time I will try to bring 100 or 1000, it depends upon the question. I will deduct or add from 100, or it can be 1000, but I will use this one. Okay, because it's easier to calculate. Okay, whenever there is 0, like this is the 100 or 1000 or 10,000, it is always easier to calculate. So here I'm taking 100 minus 1. Now using that formula, what I can do is 100 minus plus, actual formula is like this, isn't it? 100 plus x plus y. So now use the formula. So the first term r will always starts from 0. Okay, so my n here is, n is equal to the index power, that is 5. So first it will start from 5c 0, then 100 to the power 5 minus 0 and minus 1 to the power 0. Okay, plus 5c1 100 to the power 5 minus 1 and minus 1 to the power 1 plus 5c2 100 to the power 5 minus 2 and minus 1 to the power 2 plus 5c3 100 to the power 5 minus 3 minus 1 to the power 3 plus 5c4 100 to the power 5 minus 4 and minus 1 to the power 4 plus 5c5 100 to the power 5 minus 5 and then minus 1 to the power 5. Okay, see the benefit of doing multiples of 10, okay, or 100 or 1000. It is always, whenever power is given, we can just simply put at the zeros. That's why it is always easier to convert. You can make this into 98 plus 1. Okay, you can either make it into 98 plus 1 also, but what will happen when you will get 98 to the power 5? It is going to be very difficult to multiply. Okay, now using Pascal's law, Pascal's theorem, I can find out all this value, isn't it? That is for n equal to 5. First one. Next, add this to 2. Bring 1, 1, 3, 3, 1, 1. Now the first one is for n equal to 0. Second one is for n equal to 1, n equal to 2, n equal to 3. So this is 4, 6, 4, again 1, 1. This is for n equal to 4. I need till n equal to 5. So 5, 10, 10, 5, 1, 1. So this is for n equal to 5. Remember, if n is equal to 5, you are going to have 6 terms. 1, 2, 3, 4, 5, 6. One term will be added. Okay, so don't forget to put this 1, 1 at the end. Okay, so this is my 5C0, 5C1, 5C2, 5C3, 5C4, 5C, 5 values. Okay, now simply I will put the values. 5C0 is 1 into 10 to the power 100 to the power 5. Okay, 5 plus 5C1 is my 5 into 100 to the power 4. Okay, and remember, minus 1 to the power 0, it is 1 only. Anything to the power 0 is always 1. Okay, so here it is 1. Here minus 1 to the power odd, that is 1. It will become minus here. Okay, minus will be coming. So here plus 5C2 value is 10. 10 into 100 to the power 3. Minus 1 to the power even number. Okay, to the power even number means answer is plus 1. That is here it will be plus 1. Okay, so this plus 1 is getting added here, so I need not need to write plus 1. Okay, here first I will check whether plus or minus. Minus 1 to the power odd means answer will be coming in minus. Okay, instead of plus it will be coming in minus. My 5C3 is 10, 100 to the power 2. Okay, and 5C4 minus 1 to the power even number, it will be in positive. So my 5C4 is 5 into 100 to the power 1. And then minus 1 to the power odd means answer will be minus. 5C1 is 1 into 100 to the power 0. So anything to the power 0 is always 1 only. So I need not need to write this. Okay, or you can write also, no problem. So answer is 1 into 1 will be 1 only. Okay, so I hope you understand till here. So now let's calculate. Okay, 100 to the power 5. Okay, now how to put the values. Say if it was 10 to the power 5, that means 10 is multiplied 5 times. 10 into 10 into 10 into 10 into 10, like this. So how many zeros will be coming? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 zeros will be coming. Now in place here there are 2 zeros. So 2 zeros will be coming 5 times. 1 time, 2 time, 3 time, 4 time, 5 time. Okay, minus here also 5 into 1, 2, 3, 4 times plus 10 into, here simply 10 I can multiply inside, minus 10 into minus 5. Now when you calculate this, you will get your answer. So once you calculate, you will get your final answer this way. Okay. So the rest of the questions you will try to solve by yourself. That is 96. One question is there, 96 to the power 3. Using binomial theorem to evaluate, what you will do is always take 100. Okay, so that my calculation will become easier. 900 minus 4, I will get 96. Or if 101, then what you can do is 100 plus 1. Okay, like this way you will solve the other questions. Okay, so I hope this question is clear to you. Now question number 10. Using binomial theorem, indicate which number is larger, 1.1 to the power 10,000 or 1,000. Okay, now first what we will evaluate is this one and check whether it is greater than 1,000 or not. Okay, which one is greater? Either this one is, this value will be greater, or 1,000 value or 1,000 is greater. So first is 1.1 to the power 10,000. Okay, now binomial theorem formula is, you know, x plus y to the power n. I need two terms. So like the same way how we have done question number 9, here also we will try to split this 1.1 into two parts. Okay, how? Always select a number that will help you make it easier your calculation. Okay, previously I have choose 10 or 100 or 1,000 to the power something. It is always easier to calculate. Now this is 1.1. Okay, so how to get this type of values? It is a decimal number. Now here what I can do is 1 plus 0.1. Okay, now 1.1, this is 1. Okay, 1.0 is always 1 plus 0.1. You add 1 plus 0 is 1. I will get 1.1. Okay, this is how you split. Okay, so 1 plus 1.1 to the power 10,000 will give me 1.1. Okay, here I am taking 1 because 1 to the power 1,000 or 10,000, your answer will be always 1. So it is always easier to calculate. So you must select the number which will help you in making your calculation easier. So now this is in terms of binomial theorem. Now I can use the formula. This is 10,000, that is your n. Okay, this is your n. So first is NCR. Your R is 0. Okay, and first is your x value will be coming, that is 10,000 minus 0 and then 0.1 to the power 0. Okay, plus 10,000 C1, 1 to the power 10,000 minus 1, and then next is 0.1 to the power 1. Now you see many more terms we are going to get because here the n is very large, 10,000. So I cannot keep on writing. If it is only till 5 or 6, it is possible to calculate, but till 10,000 it's not possible. So what I will do is plus more terms. Okay, you cannot calculate till 10,000, more terms will be coming. Put a dot dot dot. Now 10,000 C0. Okay, so I always told you NC0. Okay, NC0 is always 1. How? Formula, put n factorial divided by n minus 0 factorial into 0 factorial. N factorial, n minus 0 is n factorial, 0 factorial is 1. And n cancel, that's why it is always 1. NC 0. So straightly here I can write 1000 C0 will be 1. 1 to the power, any power will always give me 1 only. 1 to the power 10 or 1 to the power 10,000, it is always 1. Okay. Here 0.1 to the power 0 is always 1. Any value to the power 0 is always 1. Okay. Plus 10,000 C1. Now some formulas you need to calculate also. Okay. If you keep calculating this, it is going to be, if you do with Pascal's theorem, it is going to be very huge. See, it is 10,000. That means your n will be 10,000. Here also we cannot do Pascal's theorem. So, one straight formula, NC1. Okay. N factorial divided by n minus 1 factorial by 1 factorial. Okay. So, n, if I open up, then n factorial always 1 is reduced in the next term. If I open this n factorial, then the next term will be always minus 1. It will keep on going minus 1 factorial by n minus 1 factorial, 1 factorial. So this and this I can cancel. Okay. 1 factorial is always 1. So n. This is some standard formula. Okay. These are some standard formula. Your NC1 is equal to your n only. So we did not calculate this. Straightly I can write 10,000 only here. 10,000. 1 to the power is always going to give me 1. 0.1 to the power 1 will be into 0.1 plus more terms. Okay. Now here is 1. 1 plus 10,000 into 0.1. Okay. So here we got 1 plus 10,000 into 0.1. I will get 1,000. Okay. Plus more terms will be coming. So if you calculate just the first two terms also, what you have got, 1 plus 1,000. 1,001. From the first two terms only, you can know that it is greater than 1,000. Okay, you need to calculate the third term or the fourth term. See, here you have calculated just for two terms, and from two terms only, when you do the addition, already it's exceeding 1,000. Okay, it is already 1,000 plus some more terms also will be coming up. So it is greater than 1,000. That means 1.1 to the power 10,000 is greater than 1,000. Okay. Now the same question, not same question, similar type of question you will get in your example number 3. Try to solve all the examples of this exercise 8.1. Okay. So I hope this is clear to you. Now this is question number 12. Question number 11 is same like 12. So that will be your homework. Once you can solve 12, then 11 also is the same thing. Okay. Now find x plus 1 to the power 6 plus x minus 1 to the power 6. Okay. This is my first part of the question. So first, let's find. So calculation will be big. So first I will find x plus 1 to the power 6 using binomial theorem. Okay. So n is your 6. So 6c0. Straightly I will not write minus. Straightly I will put the values. Okay. 6 minus 0 will be 6. And 1 to the power 0. Plus 6c1 x to the power 5. Then 1 to the power 1. Plus 6c2 x to the power 4. Then 1 to the power 2. Plus 6c3 x to the power 3. 1 to the power 3 plus 6c4 x to the power 2. 1 to the power 4 plus 6c5 x to the power 1, 1 to the power 5 plus 6c6 x to the power 0, 1 to the power 6. Okay. So now you see what I have told you in binomial theorem, the observations, that the first value, the power will keep decreasing, and the y, say this is your y will keep on increasing. You see here, x to the power 6, x power is decreasing, x5, x to the power 4, x to the power 3, x to the power 2, x to the power 1, x to the power 0. Similarly, y you see from decreasing to increasing. Okay, this is your observations in binomial theorem. Now you see here 6c0. I have already calculated here. Okay, first part is for n equal to 0, n equal to 1, n equal to 6. You're going to have 7 terms. 1, 6, 15, 20, 15, 6, 1. 1, 2, 3, 4, 5, 6, 7. Okay, so first value is for 6c0, 6c1, and it goes on till 6c6. So simply I will put the values. My 6c0 is 1. So 1 into x to the power 6 plus my 6c1 is 6 into x to the power 5. 1 to the power 1 is always 1, okay. My 6c2 is 15, x to the power 4. 1 square is always 1. If it is minus 1 to the power square, then that will be different thing. It will be minus 1. If minus 1 to the power cube means minus sign will be coming here. But since it is positive, so straightly 1. I am not going to calculate that. Plus 6c3 is 20. 20. My 6c3 value is 20. So 20x cube plus 6c4 is 15x square. My 6c5 is 6x plus 6c6 is 1. Okay, 1, and therefore 6c6 is 1 and x to the power 0 is 1. Okay, so c6 it will be 1 only, because x to the power 0 will give me 1. So you see, this is your answer. 1 into x to the power 6 will be x to the power 6 only. Okay, so this is for your this part, x plus 1 to the power 6. Now what will be your for x minus 1 to the power 6? Now if I don't calculate also it's okay, same thing, but the sign will be changed. Okay, answer you will get same. If you want you can do, but from here only you can get the answer. First will be x to the power 6. Okay, because here minus 1 to the power 0 will give me 1 only, and the next term is plus 6x5. So here in place of 1 it will be minus 1 to the power 1 will be minus. Okay, so 6x to the power 5. Now next is this term, minus 1 to the power whole square. So it will be plus only. So here it will remain 15x to the power 4, and here minus 1 to the power whole cube, odd number will be minus. So minus 20x cube. Here minus 1 to the power 4 plus, so it will remain same. And then here minus 1 to the power 5 minus, so it will be minus 6x. And the last one is minus 1 to the power 6. So answer will be in positive, so 1 will be coming. So now you see x plus 1 and x minus 1, you got the answer. Now you add both of them. Okay, x plus 1 to the power 6 plus x minus 1 to the power 6. Okay, first write down all the values of x plus 1 to the power 6. That is all these values. Okay, so x6 plus 6x to the power 5. Now plus, it is addition, so not a problem. Straightly I can write all the values. X minus 1 is this values. Okay, I have written all. Now let's see which are the portion we can cancel. 6x to the power 5. Here is minus 6x to the power 5. Okay. Now this is addition. This is also addition. We cannot cancel. And 20x cube and minus 20x cube. Okay. Plus 6x minus 6x. Okay. Now what are left? x6 and x6 is same, x to the power 6. So it will become 2x to the power 6. Next is 15 plus 15x to the power 4. Okay, so it will be plus 30x to the power 4. And next will be again plus 30x square plus 2. Okay, this is your final answer for the first part. Now, after finding this, my next question is evaluate root 2 plus 1 to the power 6 plus root 2 minus 1 to the power 6. Okay, now no need to evaluate like this. You see here the pattern is same exactly like this one only. Now what we will do, this above equation, say you put equation 1. Okay, now in place of x it is root 2. Okay, so putting x equal to root 2 in equation 1, you can straightly get your answer, because once you get, you're going to get the same pattern only if you evaluate. Okay, no need to waste your time. So this is your equation. Only x I will put root 2. 2 into root 2 to the power 6 plus 30 root 2 to the power 4 plus 30 root 2 to the power 2 plus 2. Okay, now how to do is root 2. If you open the root, then if you want to open any root, then value of root is half to the power half. Okay, to the power half into 6 is there, 6 plus 30 root 2 I want to open 2, then half into 4 plus 30 into half into 2 plus 2. Okay, so 2 1s are 2, 2 3s are 6. 2 into 2 to the power 3 plus 30 into 2 1s are 2, 2 2s are 4. 2 to the power 2 plus 30, 2 and 2 cancel, 30 into 2 plus 2. So 2 to the power 3 into 2, your answer will be 16 plus 120 plus 60 plus 2. Okay, your answer will be, when you add all your answer, you will get 198. Okay, 198 is your final answer. Now same you do for question number 11. Okay, so I hope this question is clear to you. Next is question number 13. Show that 9 to the power n plus 1 minus 8n minus 9 is divisible by 64 whenever n is a positive integer. Okay, that means this we have to show is divisible by 64. Now you see here, what we will first evaluate is this part. Okay, this part we will evaluate first, that is 9n plus 1. Now for evaluating, here why I am not evaluating using binomial theorem, see, power is not given anything. Okay, so that's why when power is not given anything means I will not evaluate using binomial theorem. Now this power is there. Now I have to make it, split it into two parts, that is x plus y part. Okay, so here 9. Okay, what I can do is I can do it 10 minus 9 also, 10 minus 1 also I will get 9. Okay, or I can split this to 1 plus 8 to the power n plus 1. There is a reason why I am taking 1 plus 8, not 10 minus 1. Okay, first let us solve this. Now 1 plus 8 to the power n plus 1. Now we know that if 8 is n, okay, we know the standard formula 1 plus, say my x is 1 and my y is x to the power n. 1 plus x to the power n, then it is always n, no, power. So it is in the pattern 1. Okay, 1 plus you can x or y. Okay, pattern is they are following this pattern, but I am taking for to the power n. Now using binomial theorem, power n only I can use this formula. It will be n NCR 1 to the power n minus r. So everywhere in place of x 1 is going to come. So 1 to the power anything will be always 1. So if I don't write 1 also, it's okay. Okay, because answer will be 1 only. My x will be r. Okay, like that. Here I have made mistake. The first one will be r will be always equal to 0. No, r will be always equal to 0, and 1 to the power n, okay, it will be 1 only. X to the power will be 0, plus the next term will be nc1. Okay, 1 to the power n minus 1 will be 1, so I will not write. X to the power 1 plus nc2 x to the power 2 plus nc3 x to the power 3, and it will keep going. Okay, now here the term is n plus 1. Okay, 1 plus x supposed to the power n plus 1. So simply it's going to be the same thing. Okay, it is going to be the same thing only, but in place of n it is going to be n plus 1. N plus 1 c0 x to the power 0 plus n plus 1 c1 x to the power 1 plus n plus 1 c2 x to the power 2, and it will go on. Okay, similarly for 1 plus x to the power n plus 1, simply what I will do is in place of x I will replace 1 plus 8 to the power n plus 1. So simply in place of x I will put 8. Okay, plus dot dot dot. I hope till here is clear to you. If you want to go for the fourth term also, what you will get is n plus 1 c3 x 8 to the power 3 plus n plus 1 c4 8 to the power 4, and it will go on. Okay, now n plus 1 c0, standard formula again, nc0 is equal to 1. So n plus 1 c0 will also be 1. Okay, nc1 is always n, and n plus 1 c1 will be always, it will be also n plus 1. Okay, so straightly I will put the value. N plus 1 c0 will be 1, 8 to the power 0 will be 1 only. Okay, anything to the power 0 is always 1, plus n plus 1 c1 will be always n plus 1, and then 8 to the power 1 is 8, plus. Now the rest you see. Okay, now in the question we need 64. Somehow we have to bring 64. Now you see 8 square, 8 square, 8 square I will get 64. Okay, now the remaining is, it keeps increasing, no, the 8. So I will take 8 square common, 8 square. Okay, 8 square I will take common. So here if I take common from this part, okay, then inside it will be remaining n plus 1 c2. Okay, 8 square is gone, plus n plus 1 c3. Here is 8 cube. If I have taken 8 square, then only 8 will be remaining. For the next term is n plus 1 c4. This all I cannot take common. 8 to the power 4. 8 2 I have taken, then remaining will be 8 square plus more integers. Okay, plus more terms will be coming. And here it is clearly mentioned that n is a positive integer. So this part will be some or more positive integers will be coming. Okay, dot 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 dot. We do not know the n. So this part you see. Okay, 1 plus 8n, multiply this, 8 plus 8 is a 64, and this portion will be positive integers, some positive integers. Okay, 64 into some positive integers, because this bracket you have taken 8 square common. Now it will be 8n plus 8 plus 1 will be 9 plus 64 into some positive integers. Okay, till here you got. And here you are solving for 1 plus 8 to the power n plus 1. 1 plus 8 is your 9 to the power n plus 1. Okay, I can write it that way. And if you bring this the other side, n, 9n plus 1 minus 8n minus 9 equal to 64 into some positive integers. Now you see here, from evaluating this, what you got, you have got this. Okay, you have got this equal to 64. When you bring the 64 to the other side, it is exactly divisible. This term is divisible by 64. Okay, so I hope till here is clear to you. Last line what you can write is, hence showed. Okay, or hence proved. Okay, that 9n plus 1 minus 8n minus 9 is divisible by 64. You write down the sentence. So I hope this is clear to you. Now question number 14. Prove that summation of n are equal to 0, 3 to the power r into nc are equal to 4n. That means we have to prove that this left hand side is equal to my right hand side. Okay. Now this summation, okay, if it's given like this, summation x equal to 1 to 5, that means what? My x value will start from 1 plus 2 plus 3 plus 4 plus 5. This is the meaning of summation. Okay, then x value starts from 1 to 5. Okay, so now here let's start with our left hand side. It is summation r equal to 0 and 3r and c r. This is not like the other question. Okay, so what happens is, here r starts from 0 to till n. Okay, so for removing this summation, first I will put the value. See, second line I have put the value of x from 1 to 5. So I did not use again this portion. Okay, so here also it's going to start with 3. R is 0. It starts from 0. Then n, c. I do not know the value of n, but I know the value of r will start from 0 to n. So nc 0. Okay. Next will be plus. Again it will be this time 3 to the power 1 nc1 plus 3 to the power 2 NC2 plus 3 to the power 3 NC3 plus more terms will be coming. Okay, so I hope till here is clear to you. So now r is equal to 0 to till n. That means we have to find till rn term. Okay, so 3r means till nth term. So the last term will be till nth term. So 3n nc n. This is going to be your last term. Okay. Now after this, we know that 1 plus x to the power n. Okay. See what we get, nc 0. Okay. 1 to the power. If 1 is coming, then I did not need to write 1 every time. 1 n minus 0. Ultimately 1 to the power something will be always 1. We will get 1 only. Okay. We are going to get 1 only. So I am not going to write that. So one part I will skip and x will be 0. Okay. Plus nc1 plus nc1 x to the power 1. Why? If 1 is there, then it will be n minus 1, but I will not write. It will give me 1 only the value. So next will be nc2 x to the power 2 plus nc3 x to the power 3 plus it will go on. Okay, it will go on to till it will become ncn. My r, this down part is r equal to 0, isn't it? R will go from 0 to n. You see the binomial theorem formula, r equal to 0 to till n it will go. So the last term will be ncn x to the power n. Okay. Now, if I put here in terms of x, 3, putting x equal to 3, okay, 1 plus 3 to the power n, okay, then the same value I will get nc0. In place of x only 3 will be coming plus nc1 3 to the power 1 plus nc2 3 to the power 2 plus nc3 3 to the power 3 dot plus ncn 3 to the power n. Okay. Now 1 plus 3 will give me 4n. Okay, and this portion you see nc0 30, nc1 31. This is your left hand side part, isn't it? This portion is your, the same thing you're getting here, nc0 30, nc1 31, same thing if you compare this. Okay, so this part what I'm getting is r equal to 0 part 3r and cr. Okay, this left hand side when we open up we got this, and using this formula what we get, 4n is equal to this. So that means we have proved that hence proved left hand side equal to my right hand side. Okay, so I hope this is clear to you. Now for exercise 8.2, general term and middle term is deleted according to your, as per your new revised syllabus. So we are not going to solve exercise 8.2. Okay, so this chapter is over till here.